Okay, hello and welcome again. We're going to probably go through this one just because it didn't seem like it was too long. So, we are continuing on our junior penetration tester path. Let me go ahead and close some of these out. Actually, let me start a brand new tab. Okay, great. That should be it. All right, we are going to continue on our junior penetration tester path. We are on authentication bypass. And let's go ahead and get our attack box started and our other machine started here. All right, so authentication bypass. And I did like the split screen view. So we will go ahead and try that. Oh, did it go to a different tab? Oh, wait, no, it didn't, obviously. Okay, I think it has to start up before I could go full screen because it says it right there. All right, perfect. So, authentication bypass. Learn how to defeat logins and other authentication mechanisms to allow you access to unpermitted areas. In this room, we will learn about the different ways a website's authentication method can be bypassed, broken, or defeated. These vulnerabilities can be some of the most critical as it often leads in leaks of customer personal data. Start the machine and then proceed to the next task. All right, let's do, is our machine running? Show split view. I'm gonna assume the machine is running. We'll exit split view and we will go complete. We'll know because it will tell us. It will not have an IP address where it should. Perfect. Username enumeration. A helpful exercise to complete when trying to find authentication vulnerabilities is creating a list of valid usernames, which we'll use later in another task. Website error messages are a great resource for collating this information to build our list of valid usernames. We have a form to create a new user account if we go to the Acme IT support sign up page. Oh, maybe it's not running yet. Show split screen. All right, we'll go full screen afterwards. Oh, we need to go here. Probably in our attack box. I don't know why I thought I could just go there. I wasn't thinking, didn't think fully. Did I hit it? Okay. All right, perfect. We'll go to our Acme sign up page. Do we have everything running? We do. Okay. If you try to enter the username admin and fill in the other fields with the fake information, you'll see we get an error. An account with this username already exists. We can use this existence of this error message to produce a list of valid usernames already signed up on the system by using the FUF tool below. The FUF tool uses a list of commonly used usernames to check against for any matches. Oh, hold on. Okay. So we have our command here. Let's go ahead with admin. We'll go admin at tryhackme.com maybe. Yep. Yeah, let's go ahead. That seems like a great password. Username for this account already exists. Now let's go ahead and use our command here. What does our command say? So we're using that fuzz again. Oh, look, we could just read this. In the above example, the -w argument selects the file's location on the computer that contains the list of usernames that we're going to check exists. The -X argument specifies the request method. This will be a GET request by default, but it is a POST request in our example. The -D argument specifies the data that we are going to send. In our example, we have the fields username, email, password, and cPassword. We've set the value of the username to fuzz. In FUFF the fuzz keyword signifies where the contents from our word list will be inserted in the request. The -H argument is used for adding additional headers to the request. In this instance, we're setting the content type so the web server knows we are sending form data. The -U argument specifies the URL we are making the request to. And finally, the -MR argument is the text on the page we are looking for to validate we found a username. Awesome. So now we're going to create a file called validusernames.txt and add the usernames to that you found using FUFF. These will be used in task 3. Okay, so let me minimize. Am I minimizing the right thing? Okay. Did I open this? I kind of want to keep, I kind of like this view here. So let's run our command and see what we get. Paste. Username already exists. What did we get? We got admin, Robert, Simon, Steve. Admin, Robert, Simon, Steve. Okay. So is it just the text file with just those names? So let's go with where are we? Okay. Let's go with, what was it? Admin, Robert, Simon, and Steve. Fuff names, fuffnames.txt, cat on our fuffnames.txt, admin, Robert, Simon, Steve. Okay, let's make sure we got that right. Admin, Robert, Simon, Steve. Okay, perfect. What is the username that starts with SI? That's going to be Simon. What is the username that starts with ST? It's going to be Steve. And what is the username that starts with RO? Robert. Perfect. So now we're on to the brute force task. Using the, oh, wait, was I supposed to name it something specifically? Oh man, okay. Is it MV buff into valid usernames.txt? Okay, cat on our valid usernames.txt. Okay. See, I read it and then like completely didn't even see it. Okay. Valid user names.txt. Okay. So using the valid usernames.txt file we generated in the previous task, we can now use this to attempt a brute force attack on the login page for our customer login page. Oh, I did close it out. I forgot. Let me copy link. We'll paste and go since we know where we're going, and we'll remove that password here. A brute force attack is if you created your valid usernames by pipping the output of the of directly, you may have difficulty in this task. Clean up your data or just copy the names into a new file. Cool. A brute force attack is an automated process that tries a list of commonly used passwords against either a single username or, like in our case, a list of usernames. When running this command, make sure the terminal is in the same directory as validusernames.txt. So let's grab our command here and let's see if we can look at it a little bit. Okay, we have our valid usernames.txt, which we know is in this directory we're in. Word list, the 10 million password list. And then this is our format against this page. And I'm guessing we're looking for a 200 HTTP status code. Let's see. This FUF command is a little different from the previous one in task 2. Previously, we used fuzz keyword to select where in the request the data from the word list would be inserted. But because we're using multiple word lists, we have to specify our own fuzz keyword. In this instance, we've chosen W1 for our word list of valid usernames and W2 for the list of passwords we will try. The multiple word lists are again specified with -W argument, but separated with a comma. For a positive match, we're using -FC argument to check for an HTTP status code of 200. Running the above command will find a single working username and password combination and answers both questions. All right, that's exactly what we suspected when we looked at this here. And there's a comma separating the two. Perfect. Let's run it. What do we get? For wordless 1, we get Steve, and wordless 2, we get Thunder. What is the valid username and password format? Oh, I can't. What is the valid username and password format? Username - password. That's going to be Steve, and his password is, and their password is Thunder. Right here. This is how we know that we did the password. This is how we know we did username. Right here. Username and password. All right. So it's going to be Steve. Excellent password. By the way. All right. So logic flaw. Okay. This is a lengthy one. All right. We'll try not to get too lost. What is a logic flaw? Sometimes authentication processes contain logic flaws. A logic flaw is when the typical logical path of an application is either bypassed, circumvented, or manipulated by a hacker. Logic flaws can exist in any area of a website, but we're going to concentrate on examples related to authentication in this instance. So, logically, the intended path, step 1 to step 2, step 2 to 3, 3 to 4. But the hacker goes step 1 to 4, all the way to the end. So, logic flaw example. The below mock code example checks to see whether the start of the path the client is visiting begins with /@/admin. And if so, then further checks are made to see whether the client is in fact an admin. If the page doesn't begin with /admin, the page is shown to the client. Okay. Because the above PHP code, I guess we could have read the page, read the code, but this is what the code says. If it equals this, I guess. Otherwise, do that. If the URL, okay, I guess I see it. All right. Because the above PHP code example uses 3 equal signs, it's looking for an exact match to the string, including the same letter casing. The code presents a logic flaw because an unauthenticated user requesting admin with a capital M will not have their privileges checked and have the page displayed to them by totally bypassing the authentication checks. We're going to examine the reset password function of the Acme IT support website. At this link, we see a form. We will see a form once I go to the website. All right, cool. We see a form asking for an email address associated with the account on which we wish to perform the password reset. If an invalid email is entered, you'll receive an error message like account not found from supplied email address. Let's go ahead and enter. It's probably someone's valid email address. I do apologize in advance. For demonstration purposes, we'll use the email address Robert at Acme IT support .tryhackme, which is accepted. We're then presented with the next stage in the form, which asks us for the username associated with this login email address. Oh, hold on. What does that return? It's not an email address. All right, I'm guessing their username is Robert. If we enter Robert as a username, then press the check username button, you'll be presented with a confirmation message that a password reset email will be sent to Robert. So let's go ahead and put in Robert. Okay, cool. At this stage, you may be wondering what the vulnerability could be in this application, as you have to know both the email and username, and then the password link is sent to the email address of the account owner. This walkthrough will require running both of the below curl requests on the attack box, which can be opened using the blue button above. We have our attack box running, right? We do, right? Okay. Wait, we're on the attack box. Oh, I just panicked for nothing. I'm not even, okay. On the second step of the reset email process, the username is submitted on a post field to the web server, and the email address is sent in the query string request as a get field. Let's illustrate this by using the curl tool to manually make the request. Okay, so here's our curl command. Paste. All right, we will use the dash capital H. Why doesn't it seem like I didn't say that like that before? We will use the dash capital H flag to add an additional header to the request. In this instance, we're setting the content type to application form URL encoded, which lets the web server know we are sending form data so it can understand our request. In the application, the user account is retrieved by using the string query, but later on in the application logic, the password reset email is sent using the data found in a PHP variable request. The PHP request variable is an array that contains data received from the query string and post string. If the same key is used for both the query string and post data, the application logic for this variable favors post data fields rather than the query string. So if we add another parameter, so the post to the post form, we can control where the password reset email gets delivered. Okay, let's see, what do we have here? Cool. Our HTML, CSS, mostly like HTMLs. Oh, okay. Okay, dark mode is not playing friendly for me. Let's see here. What do we have? Okay, we'll send you an email. Cool. All right, so now if we do, did it tell us what that one was for? Okay, so curl request 2, and then it's going to go to attacker@hacker.com. For the next step, you'll need to create an account on the Acme IT support. Oh, hold on. Let me just. Okay, cool. For the next step, you'll need to create an account on the Acme IT support customer section. Doing so gives you a unique email address that can be used to create support tickets. The email address is in this format: username at customer.acmesupport.tryhackme. Now return into curl request 2, but with your username in the field, you'll have a ticket created on your account which contains the link to log you in as Robert. Using Robert's account, you can view the support tickets and reveal the login. Okay, so we're going to do curl requests. Well, first we need to make our account, right? Customers, sign up here. It didn't say, so I'll just go with the name, Jane at customer.tryhackme.com. Oops, well, that's not it. Jane at, paste. Okay, our password. We need it to be something we know, right? Okay, sign up. Okay, don't save. And then we have support tickets. You have no support tickets created. And then if we run this curl command with Robert as the username and me, Jane, as the recipient, let's go ahead and remove. I think we're supposed to put us here, right? Jane. Something is amiss. Oh, we're missing a quote. Hold on. Did I hit my mic? Because I can't see. Okay. Perfect. So now we need to go back here. We don't have any support tickets created. Let me reread this. For the next step, you'll need to create an account on the Acme IT Okay, let's reread this. For the next step, you'll need to create an account on the Acme IT customer support section. Doing so gives you a unique email address that can be used to create support tickets. Now rerun the curl request, but with your Acme IT support. In the email field, you'll have a ticket created in your account, which contains the link to log in. You have no support tickets. All right, so let's try this again. But let me actually look at the command. Copy it properly this time. And then we'll paste it in here. And that looks right. And then we were supposed to remove, are we supposed to put it? Yeah, it's just supposed to say, Jane at customer. Okay, password reset sent to Jane. Why am I not seeing? Oh, wait, was that said one before? Maybe, I think that did say one. Maybe it's because I didn't pay attention. All right. We received your, we've received a request to reset your password. Please visit this copy to automatically log in and then you can reset. Okay, so let's paste and go. I probably need to, oh, I am in Robert's account. Okay, please don't tell anyone. What is the password from Robert's support? What is the flag for Robert's support ticket? There we go. So now we're in Robert's account. All right, cookie tampering. All right. So examining and editing the cookies set by a web server during your online session can have multiple outcomes, such as unauthenticated access, access to another user's account, or elevated privileges. If you need a refresher on cookies, check out HTTP Detail Room on Task 6. Plain text. The contents of some cookies can be in plain text, and it's obvious what they do. Take, for example, if these were the cookies set after a successful login. Set cookie login to true, max age. Set cookie admin equals false, max age. We see one cookie logged in, which appears to control whether the user is currently logged in or not, and another admin, which controls whether the visitor has admin privileges. Using this logic, if we were to change the contents of the cookies to make a request, we'll be able to change our privileges. First, we'll start by requesting the target page. Oh, did I copy? All right, maybe we're done. I hope I'm hoping we're done with that because I just closed out those pages. Why did I just put the curl up there? All right, I'm gonna paste that in there. Cookie test, not logged in. We can see it returns the message not logged in. Now we'll send another request with the logged in cookie set to true and the admin cookie set to false. Logged in as a user. We're given the message logged in as a user. Finally, we'll send one last request setting both the logged in and admin cookies to true. Paste. Logged in as admin. TryHackMe cookie tampering. It's probably one of our flags, but we haven't gotten there yet. All right. So hashing. Hashing. Sometimes cookie values can look like a long string of random characters. These are called hashes, which are an irreversible representation of the original text. Here are some examples that you may come across. MD5. I don't want to exit split view, but we'll just pretend like we know what's here. MD5, SHA-256, SHA-512, and SHA-1. You can see from the above table that the hash output from the same input string, the original input string is 1. I completely didn't even read the actual string. Okay, the original string. And then we apply this hash, and this is the output that we get from that. You can see from the above table that the hash output from the from the same input string can significantly differ depending on the hash method in use. Even though the hash is irreversible, the same output is produced every time, which is helpful for us as services such as crackstation.net keeps databases of billions of hashes and their original strings. Encoding is similar to hashing, that it creates what would seem to be a random string of text, but in fact the encoding is reversible. So it begs the question, what is the point in encoding? Encoding allows us to convert binary data into human readable text that can be easily and safely transmitted over mediums that only support plain text ASCII characters. Common encoding types are base 32, which converts binary data to the characters A through Z and the numbers 2 through 7, and base 64, which converts using the characters lowercase a through Z, capital A through Z, 0 through 9, plus /, and the equal sign for padding. Take the below data as an example, which is set by the web server upon logging in. Okay, set cookie session, and then this max age path. We got an equal sign here. So we know it's base 64. This string, base 64 decoded, has a value of ID 1, admin false. We can then encode this back to base 64 encoded again, but instead setting the admin values to true, which now gives us admin access. Okay, so what is the flag from the plain text right here? That's going to be TryHackMe cookie tampering. Okay, so now for this one, we need I wonder if we could use, what is the MD5 hash value for this? Hold on. Okay, so what is the value of the MD5 hash? Let's just Google it, see what comes up. Okay, this tool is telling us it's 463729. Let's put it in here, see what comes up. Okay, perfect. And then what is base 64? What is the base 64 decoded value of this? I believe we can do this one on Linux. Let's see what the command would be. What would it look like? Okay, echo, then this, type base 64, and then the word decode. And that is from Linux Hint. Oops. Oh, hold on. That's from Linux Hint. Let's bring that over so we know how we got here. Right here, example for decoding. Oh my goodness, these ads. Oh, wow. Okay, at least they're not talking. Right here. All right, so we will take this and we'll go echo with our quotes. We'll paste that into there, pipe it into base 64 decode. And then, oh, okay, TryHackMe base 64 encoding. Okay, so now we need to encode. And so I'm guessing we're going to use the same command, but the one without the extra stuff. So we'll encode this. I only need, I believe, just this part, the number right here. So we're going to go echo with our single quote around that. We'll paste in here what we're supposed to be encoding. And then we're going to pipe base 64. And that returns this value right here. Let's see. What does it say? All right, perfect. And that was Authentication Bypass. All right, are there any questions? I don't know if my headset's working now. Sometimes it just goes off on me when there's nothing planned. All right, so I think that's going to be it. We did 2 in one day. I think that's good enough. Authentication bypass and subdomain enumeration. So that means the next one we're going to do is IDOR, which I should have terminated this box right here. IDOR, not too long, but we'll definitely be able to get to IDOR next week. We have a practical example. We've got some other stuff. All right. Thanks for showing up. Have a good night.